Yes, good morning students. Last class we discussed what is the adjoint and inverse of square matrix. Okay. So in this session we shall learn some major applications of determinants and matrices. Okay. In this session we shall learn applications of determinants and matrices. See, it is very important concept. Every year, ಪ್ರತಿ ವರ್ಷ 5 ಮಾರ್ಕ್ಸಿಗೆ ಒಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ applications of determinant and matrices. So what is the main application of these determinants and matrices means? It is very major application is very easy to solve a system of linear equations. Suppose if a system of equations ax plus by plus cz is equal to d, like this, a1x b1y plus c1z is equal to d1. See, system of equations means it contains number of equations. So second equation is a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. See, the main application of these determinants and matrices is to solve easily by using this concept. Very easy to solve this system of linear equations. Means how to find the value of x, value of y, value of z. I mean value of these variables. How to solve? You will use these determinants and matrices to find the values of x, y, z and variables, right? So how to use means, let me discussion on this concept. Okay, how to use this. But take down one example to understand the concept. Determinants. Applications of determinants and matrices. So the system of linear equations. So the system of linear equations. So very first one is solve the system of linear equations. So first one is 5x plus 2y is equal to 4. And one more equation, 7x plus 3y is equal to 5. 7x plus 3y is equal to 5. As I told in the beginning, major application of determinants and matrices is to solve a system of linear equations. Linear equations means power of variable must be equal to 1, as you know, right? Now, how to solve these linear equations by using determinants and matrices means, see, this method is called the solution. Solution finding these kind of problems is, this method is known as matrix method. So first one is, see, the given system of linear equations can be written as, so the given system of linear equations can be written as Ax is equal to B matrix. Matrix Ax is equal to B. Where, so matrix A is called a coefficient matrix, a coefficients of x and y, and matrix X is variable matrix, that is xy, and matrix B is called constant matrix, where here matrix A, here A is the coefficient matrix. So coefficients of x and y. Here coefficients of x and y is, so first equation coefficient of x is 5 and the second equation, coefficient of x and y are 72. This is called coefficient matrix A. And x is the variable matrix. Here there are two variables available. We will write it down as like this. Okay, variable matrix. This is a column matrix. 2 rows, 1 column, 1 by 2. So column variable matrix is given by. Suppose if the equation solution of system of linear equations contains one more equations, means it is given by x, y, z like this. Here only two variables are there. This variable matrix x is given by x, y, that's it. And matrix, constant matrix. Matrix P is here elements constants of 4 and 5. Right there, matrix 4 and 5. See here we are going to find the value of x and y, right? So first to find values of x and y, first we need to find inverse of the matrix A. Okay. So as you know how to find the inverse of matrix A. So first consider the matrix A and find out the value of determinant. So inverse of A is calculated like this. So determinant variables. So determinant of a matrix of order 2 with elements 5 to 7, 3. Value of the determinant becomes 15 minus 14, that is equal to 1. So keep in your mind that this is always not equal to 0. If the element is not equal to 0 means, so xy is not defined. Okay, here 1 that is not equal to 0. Then adjoint of A matrix is given by. How to find adjoint of A matrix means just we have to interchange the diagonal elements. In place of 5, we have to take element 3. In place of 3, we have to take element 5. And change the sign of rest of the elements. Change sign. Plus 2 becomes minus 2, plus 7 becomes minus 2. This is called adjoint A of the matrix, right? Now, find out inverse of the matrix. You know that inverse of the matrix A is given by A inverse, that is equal to 1 by determinant A into adjoint A. 1 by determinant A into. Now inverse of the matrix becomes A inverse, that is equal to 1 by determinant A means 1 by 1 into adjoint A is 3 minus 2 minus 7 5. 3 minus 2 minus 7. This is inverse. Here we are going to find values of variables, right? To find variables, consider the equations. Ax is equal to b. Consider Ax is equal to b. Now this Ax can be written as, and shifting this A to right side, it will be 1 upon A into, or that is equal to, this can also be written as A inverse into matrix B. You know that X means variable matrix xy, that is equal to A inverse, just we follow that 1 upon 1 into order 2 matrix with elements 3 minus 2 minus 7 5. Matrix B is, what is matrix B? Constant matrix 4 5. Now multiply these two, you will get. So x becomes variable xy, that is equal to variable xy, that is equal to, so matrix multiplication. See here 2 by 2 matrix, 2 by 2 matrix, it is 2 by 1 matrix. See here number of columns in pre-multiplier matrix is same as number of rows in post-multiplier. Matrix multiplication is defined. Now multiply this one. Now on multiplication, matrix becomes 12. So 3 4s are 12 minus 10. Like that. Second one is, so minus 35 plus 25. Minus 35 plus 25, right? So this one, minus 7 into 4 minus 28 plus 25. And now xy becomes variables. 12 minus 10, that is 2, minus 28 plus 25, that is minus 3. Now equality of the matrices. By the definition of equality of the matrices, you know that equality of the matrices means respective elements of both the sets are equal. So by definition of equality of matrices, see here x is equal to 2 and y is equal to minus 3 for the required values. Which are the required values? So this method is called matrix method. So very important concept. So प्रति वर्ष 5 marks की question केलते. So you have to follow the methods to solve system of linear. Stay down like this. Next problem. Like this. Next problem. 2x minus y equals 2. Next equation. 2x minus y equals 2. 3x plus 4y equals 3. So next is 2x minus y equals 2 and 3x plus 4y equals 3. Okay, first here also same. A given system of linear equations can be written in the form of. So solution is the given system of linear equations. System of linear equations can be written in the form of. Written as Ax is equal to B. Where we know that A means where A means coefficient matrix. It also order to matrix with first one. Coefficients of xy becomes 2 1 and coefficients of second equation coefficients of xy is 3 4. And x is the variable matrix which is given by xy. Only two variables are there. Whatever. You will take down that variables like this. And B is constant matrix. Here constant elements are 2 and 3. Now first find out inverse of matrix A, right? Inverse of matrix A means to find inverse of A, we have to express the matrix A as a determinant of the matrix of order 2. So that is given by 2 minus 1, 3 4. So now the value of the determinant becomes determinant A is equal to 8, see minus of minus 3 that becomes plus 3, 8 plus 3 that is equal to 11. See 11 is not equal to 0, therefore inverse of the matrix is determined, defined. Now adjoint A, adjoint of the matrix A is given. Matrix A is 2 minus 1, 3 4 is there. Here also same. First we have to interchange the diagonal elements. In place of 2 we have to take 4 and in place of 4 we have to take 2 and change the sign of rest of the elements. Here minus 1 is there, that becomes plus 1, plus 3 is there, plus minus 3. Take out. Now we know that inverse of the matrix A is given by A inverse that is equal to 1 by determinant A equal to adjoint A. So inverse of the matrix A inverse that is equal to 1 by determinant A is 11 here, 1 upon 11 into adjoint is 4 1 minus 3 2. This is inverse of the matrix. So next we have to find values of x and y. Therefore consider the equation. Ax is equal to b. Ax is equal to b. And here x can be written as A inverse into matrix. So x becomes, x means we know that variable matrix xy, that is equal to A inverse is 1 upon 11 into matrix is 4 1 minus 3 2. Matrix is constant matrix, elements, column elements 2 3. So also matrix multiplication, so variables xy equals 1 upon 11 into, so 2 by 2 matrix multiplied with 2 by 1 matrix, so you get 8 plus 3. So next minus 6 plus 6. So minus 3 into 2, that is minus 6 plus 2 into 3 plus 6, that is equal to 1 upon 11 into 8 plus 3 is 11 minus 6 plus 6 that. So now values of x and y, that is equal to 1 upon 11, or multiplying the scalar quantity 1 by 11 to each element of this matrix, we will get 1 by 11 into 11, that is 1, 0 into 1 upon 11, that is 0. So by definition of equality of matrices, here respective elements of both the sets are equal to each other. So by definition of equality of matrices. So we will get x is equal to 1 and y is equal to 0. So required values x and y are 1 and 0. Okay, like this 3 by 3 matrix. See, sum of equations contains 3 variables x, y and z means, then it becomes next one. Like this next problem, 2x x minus y plus z is equal to 4. Next, x minus y plus z is equal to 4. So one more equation is 2x plus y minus 3z equals 0. lastly 2x plus y minus 3z equals 0. X plus y plus z is equal to 2. X plus y plus z is equal to see, the procedure to solve this problem is same as followed in the last problem. There also, so first the given system of linear equations can be written as expressed as ax is equal to b. See, in the last problem only two variables are present. In this problem there are three variables x, y and z. Take down. So where matrix A means where also the given system of equations can be written as ax is equal to b. A means coefficient matrix. Coefficient matrix is 1. Coefficient of x in first equation 1, y is minus 1, z is plus 1. And second equation 2, 1, minus 3. Lastly, so 1, 1. And matrix is variable matrix x, y. And constant matrix here x, y, one more variable is there, that is z. And constant matrix is 4, 0, 0. 4, 0, 0. 4, 0, 0. So now we also first we have to find inverse of matrix A. Inverse of matrix A. So this is 2x plus y plus z is equal to 2. See, this becomes constant matrix is 2. For coefficient constant becomes 4, 0, 2. And constant matrix is 4, 0, 2. Now inverse of matrix A. To find inverse of matrix A, so we have to express the given matrix in terms of determinant of a matrix of order 3. So determinant of a matrix of order 3 elements becomes first row elements 1, minus 1, plus 1. And second row 2, 1, minus 3. And lastly 1, 1, 1. So find out the value of the determinant of A. So value of the determinant becomes determinant A is equal to expansion along first row. So we will get expansion along first row. So first row. Value of the determinant A is equal to. So determinant sign is first row first element plus is determinant element 1 is there deleting first row first column. Determinant is 1 minus 3 1. So next first row second element determinant sign is minus. Your element is minus 1 is there minus of minus 1 becomes plus 1. Deleting first row second column. First row second column determinant is 2 minus 3 1. 2 minus 3, 1. Now, first row third element, determinant sign is plus, element is 1 is there, 1 now. Deleting first row third column, determinant is 2, 1, 1. Value of the determinant becomes, it is equal to, so 1 plus 3, 1 minus of minus 3 plus 3 plus 1 into 2 minus of minus 3 plus 1 into 2 minus 1 is equal to 4 plus 5 plus 2 minus 1 is 1. Say 6 plus 4 plus 5, 9 plus 1 that is 10. Your 10 is not equal to 0. Now find out inverse of the matrix. To find inverse, first we have to find adjoint here. So to find adjoint here, first we need to find cofactor matrix. Cofactor matrix is cofactor of matrix A becomes. So cofactor of matrix A is what? So cofactor of matrix A written as cofactor matrix is equal to first take down first row first element, determinant sign plus, then minus, first row second element, and finally plus, cofactor matrix. Second row cofactors, determinant sign minus, plus, minus, and last plus, minus, plus. Cofactor matrix becomes, that is equal to. So now cofactor matrix. So deleting first row, first column, matrix becomes 1 minus 3, 1. So this one, 1 minus 3, 1. Sorry. So next row, deleting first row, second column, it becomes 2 minus 3, 1, 1. So deleting first row, third column, it becomes 2, 1, 1, 1. So second row elements are deleting second row, first column, treatment is minus 1, 1, plus 1, 1. So next second row, second element, deleting second row, second column, treatment becomes 1, 1, 1, 1. So now cofactor of second row, third element, deleting second row, third column, 1 minus 1 plus 1 plus 1. So like that, third row elements becomes deleting third row, third column, the first column, determinant is minus 1, 1, 1 minus 3. Minus 3, okay. Now deleting third row, second column, determinant becomes 1, 1, 2 minus 3. 2 minus 3. Lastly, deleting third row, third column, determinant is 1 minus 1, 2, 1. 1 minus 1, 2. This becomes cofactor matrix, right? So now find out the values of the determinant. So now the values of the determinant becomes, say first one is 1 plus 3, 1 minus of minus 3 becomes plus 3, like that. So minus of 2 plus 3, like that, plus 2 minus 1. Second row elements are minus of minus 1 minus 1 plus 1 minus 1. So minus of 1 plus minus of minus 1 becomes plus 1. Like that, third row elements becomes, so minus 1 plus of minus 3 becomes minus 1 into minus 3 becomes plus 3 minus 1. Next element, minus of determinant sign minus 3 minus 2. Lastly, plus of 1 minus of minus 2 becomes plus 2. That is equal to cofactor matrix. So 1 plus 3 is 4, minus 2 plus 3, that is minus 5 plus 1. So minus of minus 2 becomes plus 2. 1 minus 1, 0. So minus 2. Last row elements are 2. So minus 3 minus 2 minus 5 becomes plus 5. So 1 plus 2. Cofactor matrix. So now adjoint is, as you know, adjoint of matrix is the transpose of a matrix where elements are cofactors. Okay. So now we have to take first row elements as first column elements. So first column elements becomes in the adjoint matrix 4 minus 5 1. Second row, second column elements are 2 0 minus 2. And lastly, third column elements 2 5 3. 2 5 3. This is the adjoint matrix. So now inverse of the matrix is given by A inverse is equal to adjoint here, A inverse written as next is A inverse written as, we know that inverse of the matrix written as A inverse equals 1 by determinant A into so 1 by determinant A is A inverse matrix, that is 1 by determinant A is here 10, 1 upon 10 into adjoint A matrices. So first row elements 4, 2, 2. Second row elements minus 5, 0, 5. And last row, third row elements 1, minus 2, 3. Minus 2, 3. 1, minus 2, 3. Right? This is the inverse matrix. Here, we have to find the variables, right? We know that. Now, variable matrix X can be written as A inverse into A. Where we know that matrix X means variable matrix X, Y, Z, and A inverse is 1 upon 10 into 1 upon 10 into first row elements 4, 2, 2, second row elements minus 5, 0, 5, last row elements 1, minus 2, 3 into here constant matrix B is, so constant matrix B is 4, 0, 2, 4, 0, 2, right? 4, 0. Multiplication of these two matrices becomes 1 upon 10. So X, Y, Z matrix 1 upon 10 matrix multiplication. So for 16 plus 0 plus 4. First row element. So next second row elements minus 20 plus 0 plus 10. 20 plus 0 plus 10. Plus 0 plus 10. So last row elements 4 plus 0 plus 6. Plus 6. And this becomes 1 upon 10 of 16 plus 0 plus 4 becomes 20, minus 20 plus 0 plus 10 becomes minus 10, and 4 plus 0 plus 6 becomes 10. On multiplying the scalar quantity to each element, it is equal to 2 minus 1 plus 1. This is the value of x. Now by definition of equality of matrices, therefore by definition of equality of matrices, by definition of equality of matrices, see here, you get x is equal to 2, y equals minus 1, and z is equal to plus 1. X equals 2, y is equal to minus 1, z is equal to plus 1. That's it, okay? Hope you understood this. Hope you understand this, okay? It's a very simple program. Take down one more example.